If we look at an organizational network, we'll see it consists of many end users and a few routers, when part of the routers provide internal service. Additionally, we want every component in the network to have an IP address, and of course, give the organization full control over information coming in and out. If these are the requirements on the one hand, and the reality is a lack of IPs, what are the solutions? A possible solution to a lack of legal IPs is to construct an internal network with access to the external network. Every internal network can share internal addresses out of set ranges, thus helping the address deficit. With this method of distribution, different internal networks can contain the same addresses. Furthermore, with this distribution, the outside world recognizes the entire network as one IP address. This allows, on one hand, all the traffic to enter and exit through one point, and it makes exposing the network structure difficult. The example shows an internal network on the right, and all the IP addresses inside it are from a range allotted to internal networks. Note that the router with one foot in the internal network and one in the external. Therefore, the IP addresses at the router's feet are different. The world reads all messages leaving the network as though they came from one IP address. In this example, we'll see how the Network Transition Protocol component, also called a NAT, deals with this. The computer sends a primary message to a web service, and the origin address and port are internal. When the message gets to the NAT, it changes the origin address to the external address, and it can change the origin port if needed, thus adding a listing to its table, which contains information about the internal port address and which external address and external port substituted it. When the message returns from the server, it's easy to substitute both the destination address and the destination port, and route the message to the right computer in the internal network. Of course, if a listing like that already exists, we're talking about messages from an opened connection, so you only need to look up in the table what port address to swap to. Inserting a NAT component into the network allows the organization to give up the purchasing of unnecessary IP addresses, and allows the component to control the outgoing and incoming traffic, and simultaneously not expose itself. The use of the NAT component has some disadvantages. In this example, we've seen that when a connection is established with a partner outside the internal network, a NAT listing opens. But what happens if there is a communication entry into the network in order to receive a specific service? How will the NAT know which end component the information should be transmitted to? The first connection solution is static and requires manually entering a NAT entry. A more advanced connection solution is using a protocol between the app and the NAT, which allows the end component to communicate directly with the NAT and open a listing via the protocol. An additional solution derives from the question, what are friends for? The two network components wanting to establish communication have to do this by connecting to a third party. They create the connection. That's why the NAT knows how to cope with it. And then the connection is established using a third party. For example, in certain cases, like Skype, in which every client is connected directly to the server, therefore the software can, using the server, ask the client to connect to a third station, as you see in the image. If you don't know something, ask. That's why we have stun servers, which allows us to know whether we are behind a NAT component or not.